Hey everyone, thanks for sticking around. Feel free to just jump in and ask questions since there's only a few of us. So, yep. Uh, this is infrastructure as code. What developers need to know. Quick intros. I'm Mike McCabe, CEO of Cloud Security Partners. We do a lot of cloud security work, application security work, and we've done a lot of big infrastructure as code projects, since that's what this talk is about. So, how many folks are familiar with Terraform? Anyone use Terraform? Yeah. Okay. Cool. So I can skip this slide. But huh? Every day. There you go. Good. Perfect for you. This is the talk for you then. Then obviously, Terraform infrastructure as code. We used to do the clicking around, creating EC2s in the console. Now we're writing code to change that. So the benefits, obviously, so we have codified infrastructure, we have consistent infrastructure. You can centralize your deployments versus having every single person go into the console and click around and create infrastructure. And you can also apply security controls, which I'm going to talk about as well. What are some of the downsides? I'll just ask you all. How do you deploy Terraform?
Yeah, myself, I use an AWS role which has a lot of permissions
Yeah.
on every single AWS account.
Yeah.
Because we manage like 3 or 4.
Yeah, exactly. Yeah, so everyone just gives the Terraform pipeline, like the admin access policy in AWS, which I understand why people do it. You have to get the job done, and it's supposed to provision resources, so it has to have that role. I'll get into how you should pull that back a little bit, but yeah, a lot of people do that. The interesting thing about Terraform is you can execute code a few different ways, so it's not really a code execution method, but there are ways to do it. Also, a really great way to gather data about an environment, and there's some interesting side cases with how Terraform works that you can use to bypass security controls. So, my experience and our company's experience, we've helped some large financial organizations move into using Terraform. A lot of them were CloudFormation or just manually creating infrastructure. So we helped them move to Terraform, also helped them build hundreds, if not thousands, of rules to basically secure their Terraform. So now when they do deployments, there's no security findings in their cloud environment, whatever goes through the Terraform pipeline, which I know sounds crazy, but it actually is true. We do kind of monthly reviews where we look at every single thing that Terraform has deployed, which is hundreds of resources, with like a Wiz.io or another security tool, and see no security misconfigurations from Terraform infrastructure. You still see things like patch management, containers being out of date, things like that, but there's no like public S3 buckets or misconfigurations, things like that. So it's a really powerful preventative control to do it, to do security in your infrastructure as code. You can also map it to your internal and external controls as well. So you all are already familiar with this, but this is what a typical pipeline looks like. If you've ever worked with any CI/CD pipeline, you know what this looks like. You push your code to the left side. In the middle, you have Terraform Cloud. You don't have to use Terraform Cloud, but it's one of the options out there. And then on the right side, you have it actually access your AWS, Azure, whatever it is, and create the infrastructure. So not different from app CI/CD, really. So how does Terraform work under the hood? This is pretty important from a security perspective, but there's the two kind of parts to it. You all know this. You do a Terraform plan. It takes your Terraform code. It looks to what are you going to build, what's already out there, what are the dependencies that are in the code. So the classic example I always use is if you're referencing a KMS key that doesn't exist, it has to create that KMS key first, then it can assign it to an S3 bucket or EC2, something like that. So that's a really important piece when it comes to security as well, because there are certain edge cases with what are called after unknowns, or the unknown values that impact security. And then once it does that, it creates your plan file. You do your Terraform apply. That's what actually creates infrastructure, reaches out to the cloud, creates your EC2, your S3, all those kinds of things. So you all are already familiar, but the great thing about Terraform is very little code needed to build, whatever your infrastructure is. Obviously, as it gets more complex, you have a lot more code. You have modules. Things get more interdependent. There's more code, but to get started, you really only need to define a provider. In this case, it's AWS, and then you define some resources, and that's all you really need. But under the hood, that's hard to read. Under the hood, this is what a Terraform plan looks like. So if you do a Terraform plan, you can change it to output as JSON. It's actually a binary format. You can output it to JSON. Do you guys ever do that just to review it? So as you can see, even with a really simple example, there's actually a lot going on behind the scenes. Terraform and AWS are going to make a lot of assumptions for you to basically define a lot of things. If you're not setting like a security group, AWS or Terraform is going to set a security group for you, and that can have important security implications. I think the really interesting one right there is get password data. So you can use Terraform to get password data. That's only for Windows EC2, but interesting field to look at. And then there's Terraform state. Do you mind saying how you store your state file?
Yeah, I store it in S3 buckets.
Okay. Yeah, that's a pretty standard way.
And then we store the local files in
Okay. Yeah. That's a pretty standard way, S3 and Dynamo. So the Terraform state file is really important because after you do that plan, one of the biggest features of Terraform is that it's stateful. So before it's like you create your EC2 in the console. There's nothing tracking the state of that. It's just it exists. It can change. There's nothing making sure that nothing changes between what you want and what actually exists. What Terraform basically created was maintaining the state of the environment, and that's done in the state file. That's really important because it has all the information about your environment. If you provision your entire cloud infrastructure through Terraform, that's going to be represented in your state. It's used for making updates. It's used for drift detection. But the really big thing is it also holds your secrets. So this is kind of hard to read. I don't know if I have a better. Yeah, it's hard to read. But this is an example state file. If you do something like create a secrets manager secret in Terraform, it's going to end up in the state file, and that's going to live in your S3. So if you make your S3 public and people get access to your state file, they have access to all your secrets. So you really shouldn't use Terraform to provision secrets. You should use something outside of Terraform to do secrets management. But people do it. That's the way it goes. And even with things like RDS automatically creates a master password when it creates the instance. That gets stored in the state as well. So basically, the state file is a huge source. If you're an attacker, if you're a red teamer, if you find a state file, just start digging through it to see all the different secrets that are out there. And even if there's no secrets, you can look and see kind of the different configurations, what networks talk to what resources exist, all those kinds of things. So the state is a pretty important file that people just sort of ignore a little bit. And so you might be able to read this, but this is from the AWS, the Terraform GitHub repo. So someone said, this is in 2014. Someone said, we want to address how do you fix having secrets in your state file? What is HashiCorp's plan who makes Terraform? What is your plan for addressing this issue? So that was 2014. This issue is still open. I took this screenshot last year, and Omar, who I've called out every time I've done this talk, basically saying like, hey, we're aware, he's from HashiCorp, we're aware, it's on the backlog, we're going to figure something out. And I just took this screenshot today. The last comment was from 2 days ago. It's still open. Nothing's changed. There's no roadmap for how to address this from HashiCorp. Like they don't have an actual plan to do anything about this. So the point is, it's kind of a big hole in the security model for Terraform that you have to be aware of, and you have to make sure there's nothing really wrong with using S3 as a backend, but it takes like 3 clicks in S3 to make it public, so that can be a big issue. I was also looking at, are you familiar with OpenTofu? So HashiCorp in last year basically changed the open source license for Terraform to be like a business friendly license, which means they can come after you if you use Terraform in like a competitive way. So if you're familiar with like Spacelift is a competitor to their Terraform cloud environment. So people were upset about that, and they forked it, and they made something called OpenTofu. And they actually have started addressing this from kind of the get-go. Like they have this as a foundational thing that they want to address by encrypting the state. So it's actually good to see that, even though the massive corporation behind Terraform is not addressing it, the open source community is addressing it. So here's hopefully you can read this, but here's your one meme for the talk. So where should you store your state file? I think this is a very consultant type of answer. It depends. I'm not going to say it should be in S3 because what if you're really bad at managing S3 protections? What if anyone can change the protections on S3, and when they decide to push some files up into an S3 bucket that has your state file, then they need to make it public because it's like hosting JavaScript, and there's no controls in place to prevent that. That means your state file is public. So it's really not about what the best location is. It's about what your organization can secure the best. So that might be S3. Terraform Cloud has built-in state management, but again, you can misconfigure those permissions, and then you can make that public too. Spacelift is the other organization that has a hosted Terraform tool that also manages the state. So it's really not about there's one best solution. It's where you can make sure you can protect that file. So another part of Terraform itself doesn't do a whole lot. It's a language specification. All the magic is really in the providers. The providers are the glue between Terraform and all your different APIs. So you can write a provider for almost anything. I found there's a Domino's provider. There's like all types of IoT type providers. Obviously, Terraform started for cloud configuration, cloud infrastructure. So there's a dozen providers for different cloud environments. Obviously, all the big ones are covered: Azure, AWS, GCP. But these are just the providers that HashiCorp themselves gives you. They actually have more than this. There's tons and tons of open source providers as well. One thing that we don't think about when it comes to infrastructure as much and the tooling we use there is how many dependencies we have and how much code we're trusting. So this is a screenshot I took about a month ago. The top one is from about a month ago. So this is the AWS provider. I just basically ran a tool that gives you the lines of code. So what matters is Terraform is mostly Go. There's 2,018,571 lines of Go for the AWS provider. That was February of this year. I took this screenshot today. There's now 2,041,948. So in a month, they added 3 million lines of code to the AWS provider. So imagine trying to secure, we always talk about dependencies when it comes to security. Imagine trying to secure, that much code. And that's just one provider. You're probably going to end up using 5 to 10 different providers depending on what your use case is. So this is all, this is code that's maintained by HashiCorp. And so they have some level of control and they do some, some level of review. But even with well-managed libraries, we've seen things, sneak in that are malicious. So, and that's just one provider. If you're using open source providers that aren't maintained by anyone, you're introducing a lot of risk in that way. So there's also, if you're using something like Terraform Cloud, or if you're using Spacelift, you have all these APIs that are used to manage. You can manage the state file through them. You can manage, planning. So you're adding another level of attack surface to how you use Terraform. We see this with people who are using Terraform Cloud. They may want people just to run plans, but not give them access to the state file because, again, secrets end up in the state file. But this is always tricky because they're trying to give them developers enough to get their job done without kind of over-permissioning their workspaces. So it's really tricky. It's a larger attack surface. If you're just running Terraform from a Jenkins server, this doesn't really apply, but you may eventually use a hosted service to run your Terraform. So another area that has a lot of security implications is the logging around Terraform. So generally, when you use Terraform, it has to assume a role. It has to assume like an EC2 role where Terraform is running. Even if you're running it in Terraform Cloud, it has a role that's tied to your AWS account. And so when it goes to do that assume role, for some reason, HashiCorp, if you turn on the tflog environmental variable, you turn it on to like trace or verbose, it will dump out all of your session information. So in your log file, you basically will have the EC2 STS metadata response in your log file. So if you're a malicious, if you're an attacker or if you're a malicious insider, a developer has access, you can just turn on the tflog file, tflog variable to like trace, run, if you're using a privileged role, run a plan, dump that out, take it outside of your environment, do whatever you want with it. So it also means these log files are very sensitive too. So another just kind of area that that HashiCorp doesn't do a great job of securing. They've made some improvements over time to try to redact some of this. I think they're now redacting the session token, but it's also provider by provider. So if you're using a different provider, it might not have that. So something else to think about. So I like this. Image because it's hard to read, but it basically says for use by competent people only, meaning that this is an electricity tester, someone used this without knowing what they're doing and probably got shocked. So that's what I feel Terraform is. It's a really awesome tool, but you have to be kind of aware of what the issues are with using Terraform. So during our time building infrastructure as code projects, we've learned a few different, these are just kind of scratching the surface, but a few different ways you can actually execute code in Terraform environments that can be useful. It's definitely useful if you're a malicious insider. It can be useful if you're red teaming and you get access to like a Terraform workspace, or you just get the ability to push to a repo that gets picked up by a pipeline. These are a couple of them, but there's as I said, the AWS provider, huge amount of code. Terraform itself, huge amount of code. This is just a couple of the probably dozens of different techniques you can use. So the first one is called remote exec. So Terraform is meant to provision infrastructure. It's not meant to do kind of endpoint configuration. So people probably use like Chef or Puppet or Ansible. Those are meant for configuring your operating system, like all the packages you need, whatever dependencies you need. Terraform wants to stay out of that side of the house. It wants to just set up your infrastructure, wants to manage that piece, and let you do all that stuff on your own. But it gives you the ability to run scripts on your servers using something like remote exec. This becomes an issue because you're then combining something like Bash, combining Python, and Terraform all together. And people are kind of bad at, they might review your Terraform, they might not look at the script that's stuck in like /scripts. So if you're an attacker, what you can do is if you get access to run a Terraform pipeline, but you can't access production directly, this is really hard to read, but basically you use remote exec, and what it does is you set up an EC2 instance. You say, once the instance is set up, run this command on the EC2. In this case, what we're running is netcat to create a reverse shell back out of your production environment. So I give this talk, and people, if you work at a startup, if you work at a small company, you probably can access production already. You probably can just like SSH in straight from your VPN. Hopefully not your house, but at least your VPN. So some people don't think it's very relevant, but if you work in like a bank or a more regulated environment, you're not supposed to be able to just get into production. You have to do change control. You have to do break glass. And really, most people should not have access to production. But this is a way to basically bypass all of that, to run whatever you want to run on the endpoint, set up whatever you want to set up. If you want to, remove like the EDR that gets automatically installed, do you want to put a backdoor somewhere? You can just use remote exec to basically do that. It'll just run as part of your pipeline. So you need to explicitly look for these types of things in your infrastructure as code pipeline and your security around that. So another one is local exec. So remote exec runs on the server that you created. Local exec runs where you run Terraform. Again, it's meant just to basically introduce scripting into using Terraform. HashiCorp even says use provisioners as a last resort. So they don't really want you using this, but they give you the ability to do this if you need to. I often see this when people are setting up like RDSs and you're setting up a big cluster. It might take a long time and you want to run some like bootstrap script after they're set up. So you run local exec, Terraform does its thing. It starts just basically waiting for those RDS instances to set up. You run a script and you finish your Terraform. Perfectly valid use case, but you're introducing scripting into Terraform. That's not really how HashiCorp envisions it being done, but people do a lot of this. The other thing is it uses the role, you're running as the role that Terraform is running as. So if you're using admin, this is running as that. So whatever script you want to run with that role, you can. So the example I always use is if you can run local exec, you basically, again, hit the metadata service, you dump out the credentials, take that outside of your network, and just start doing whatever you want to do with your admin role or whatever role you give Terraform. This is actually fun to mess with if you have any. Like Spacelift does the same thing. It assumes a role. It has metadata service. If you run local exec, you can start kind of interrogating the server that Terraform is running on. Same thing with HashiCorp Cloud. They've fixed this in the past year or so, but before a while, you could actually hit the metadata service and do a bunch of things on that server. You can still run local exec, but you can't hit the metadata service anymore. But in this example, we're basically hitting that, curling it out of the environment. As an attacker, I run this, I get the session token, I start using that to do whatever I want to do in the cloud. So a way to prevent these types of things, just like we have on the app side of the house, we have to have CI/CD security controls. We have to have things running, checking our code, testing for these types of things. We're a big fan of semgrep. People familiar with semgrep? No? So it's basically a pattern matching language. It's open source, but there's a paid version of it too. It's very much kind of like regex, but it's different because you can actually have context that goes through. You can do kind of more complex relationships with semgrep. But the nice thing is it's really easy to get going. It's free and it's fast. So even if you're not using Terraform, use semgrep against your code base because it will find some things. So that's really hard to read. So this is an example. You're basically defining a pattern. Pattern inside basically saying inside this thing, which is provisioner. Language is just generic. And then down there we have include star Terraform files. So basically we're saying look at every single Terraform file and see if there's a provisioner defined. So that's remote exec or local exec. You run this in your CI/CD. You say break the CI/CD if this gets found. And you prevent people from introducing this into your code base. So it's if you're using GitHub Actions to do CI/CD, you can install this in 5 minutes. Otherwise, you can just install it in Jenkins really easily too. So again, there's a paid rule set that more rules. It's not that big of a difference. So definitely run free at least against your code bases, even if it's not Terraform. If you're using PHP, Ruby, whatever, Java. Run it against those as well. So it's a good tool. So there's some other things you can do with Terraform that are kind of built in, which is interesting. In Terraform, there's this whole idea of data versus resources. So there's the resources that you manage, so your EC2s, your RDS, S3, whatever. Those are managed resources. And then data is basically static data. It can be something like a JSON structure. It can be just literally text. But there's a few built-in methods that are interesting because there's one that's the HTTP provider, which is just basically a built-in HTTP GET provider. So again, this example, I'm using that to hit the metadata service to dump out the credentials, and I can then use that elsewhere. So when we're doing these projects, we're trying to build these really locked down Terraform implementations so we can trust thousands of developers to just, to run their own Terraform without it being reviewed by security. We had to build all these security rules, and we just kept finding more and more examples of ways you could abuse Terraform to do these things. In general, you don't want to give developers super high privilege access to your entire cloud environment. You want to give them, limited access to what they need to do. So you have to find these techniques and then block them from being used. So there's a lot of different ways you can use Terraform to abuse that. So this is what you see when you run that. It's just doing a GET request against the metadata service. It's dumping out to STS credentials. And a developer just has to look at the logs, or a malicious user just has to look at the logs, and they have that credential again. So this is really hard to read, but another semgrep rule, you're just writing pattern, data, HTTP, anything, and anything means anything. It just means look for these two things, then anything afterwards, and flag it. So it's a really easy tool to use. So external data is another. It doesn't make any sense how they name these things, but basically external data is another way to run scripts in Terraform. People use this if they need to run some script during the apply. It's called data, but really you're just running whatever you want to run. So if it's a Python script, if it's a Bash script, whatever it might be, you can use external data to do it. So in this example, the idea is we're hitting a secrets manager secret. We're feeding that in as a variable called secrets. We're running a Python script, exfilldata.py. Can't be any more obvious than that. But it's another way you can just run scripts as part of your Terraform pipeline. So again, another thing you have to check for, you have to prevent people from using. Otherwise, you can just abuse your Terraform pipeline. So beyond semgrep, there's semgrep is really good for basic pattern matching. It's a really good tool. It's fast. That's all well and good. But when you get into more of a policy as code environment where you want to build really robust and kind of logical controls, like if production, you can't do this. If development, you can't do this. Semgrep gets really flaky with doing that. You can do it, but you're doing kind of like pattern matching instead of logical checks, instead of just kind of equivalent checks. So there's a few tools out there that we've used that we like that are meant for more policy as code, where you can actually write code to enforce all your security policies. And that's how we ended up, deploying cloud infrastructure through these Terraform pipelines that is 100% compliant and 100%, quote unquote secure. So HashiCorp has their own. It's called Sentinel. I'm not going to say it's the greatest tool. I don't think that people should just keep recreating their own language for everything, but that's what HashiCorp decided to do. OPA is another tool from, or Rego is another language from OPA. OPA is the Open Policy Agent, if you ever heard of that, but that's a whole suite of tools to do things like policy as code. Both of them are meant for more than just Terraform. Sentinel can be used on like HashiCorp Vault and things like that. Any HCL it can be run against. OPA can be run against almost any language, sort of like semgrep. So, but you have to build rule sets. So what do these look like? So this is a Sentinel example. Is really basic. What we're doing is we're importing the plan file. So we're getting all the information about what's about to be created. We're defining some allowed types. This is EC2 instance sizes. We're going through the plan and we're finding all the AWS instances, all the EC2s. And then we're doing this filter on line 9 that's basically saying, take all the EC2s, take all the allowed types, and look at the instance type to make sure that it's in this array of allowed types. And so you can integrate these tools into your pipeline. Unfortunately, Sentinel, you have to use Terraform Cloud. You can't just run it in Jenkins, but because it's a HashiCorp product. But it's still a pretty decent tool. If you're already using Terraform Cloud, it's probably good to adopt this versus something else. But really easy to write. You can write, dozens of these in a day because they're so simple. So if you just have your security rules that you want to enforce with your Terraform pipelines, you can write these super quick. This one's a little more complex. This one, we're defining a role that we want Terraform to assume. Then we're going into the provider configuration, and then we are basically saying, does this provider configuration, is it using the role we're supposed to be using? So you can make it, it can do more complex things than just kind of basic pattern matching. But the good thing is this is still 29 lines of code with white space. So it's not a lot of code to do something really important, like enforce the role you want to use. So people aren't setting your admin role, they're setting, the setup EC2 role, something like that. This is Rego, so not completely different. You're importing the plan file. You define a couple of functions. You're defining these rules. Everything is kind of a rule of what you're saying should be or shouldn't be done. In this case, we're checking the encryption on a root device. And it's just, again, doing a basic, is a value true? So root device dot encrypted equals true. That's all it is. It's very simple. I'm not a huge fan of OPA because of how you do the actual definitions of rules. You do this thing called not disambiguation, just like disassociation, where you write a bunch of the same policies over and over again. You just tweak one thing. It makes it read very strangely. It's hard to reason about everything that's going on. But if you don't want to pay for HashiCorp Sentinel, you can use this instead. So another thing to think about is you want to use something like semgrep in your CI/CD pipelines before you run your Terraform plan. So it's really good at working off of your actual HCL code. HCL is what you write. The plan is what Terraform generates based off your HCL. So semgrep would kind of go between you committing code to the repo and before it goes up to Terraform Cloud. Tools like Sentinel or OPA, they run after the plan's already been done. So there's kind of important things to consider about that because there's some values you're not going to know until a plan is run, and there's some relationships you're not going to know until a plan has been run that you just can't do in semgrep. So semgrep's good for really basic pattern matching, but if you need to do more complex things, you have to rely on the plan, and that's where Sentinel, which is a more fully featured language, is useful. Come on. So again, this is just kind of showing you have your GitHub on the left, your SCM, you have Terraform Cloud, plan runs, then Sentinel runs, then you do an apply, and you have your new infrastructure. So I touched on this before, but after unknown values are basically, like we talked about before, if you're defining an S3 bucket and it has a KMS key, if you're also creating that KMS key, it doesn't know what the values of that are until it's created. So Terraform will reach out, it'll create that KMS key, an ARN will be generated from AWS, it gets passed back to Terraform, and then that's entered into the part of the plan for the S3. So that has a security impact because if you don't know what a value is, how do you validate that it's right? If you want to make sure that that KMS ARN is like the correct key for that bucket, how do you validate that if it doesn't exist, if it's an after unknown? So if you actually look at a Terraform plan file, there's this section called after unknown, which is basically you have your before, which is the current state, you have after, which is what the state's going to be, and then you have after unknown, which is we don't know what it's going to be until the apply is run and the API gives us back the response. So if you write a rule, like a Sentinel rule to say, if this value equals this, fail. But if that value doesn't exist, how do you validate that? So you run into an issue where if something ends up in the after unknown block, your policies might just completely silently pass, even though they're technically violating. So we ran into this. This is just kind of the way Terraform works. It's a stateful language. It's maintaining and tracking the state. So there's no way to completely avoid this except for doing explicit checks in your plan file for after unknowns and basically saying, if a value is after unknown, fail the plan. There's no other really way around that. We've done some things with doing more hard coding of values from modules and doing more of associations or trusting modules for certain things. But a lot of times we just basically say you can't have after unknown values for important values. So talking about some more solutions, I think the most important one is probably IAM, how you build your IAM policies. I think we're all bad at this until you like really take a firm stance at creating more secure and more structured and limited IAM policies. Everyone really struggles with creating very locked down policies until you really take we have a process for building these policies based on what we need. I've seen a million Terraform pipelines that just have admin access, and so there's no restrictions at the role level of what that Terraform pipeline can do. Beyond that, we should be building patterns for how we use these. Code review, I kind of talked about. And I'll talk about a couple of the things before we wrap up. So I think the biggest, Sentinel was great, SemGrep is great. They're good tools to integrate, but the first step should always be how you define your IAM to restrict Terraform the most. If Terraform isn't creating something, don't give it access to do it. So if it's not creating IAM policies, if it's not creating network resources like subnets or security groups, don't give it those permissions. Basically, start from where, what does it need to do? Start there, and then build as you go. That gets really hard because we run into this too, where you basically say, okay, give it EC2 create, then you do a run, then it hits some issue with the IAM. It's going to do another run. It's a pain. I'm not going to say it's easy. AWS has a tool that's part of Access Analyzer where you build something and then it looks at CloudTrail and says, what are all the different things you did? And then it creates a policy based on that. That's handy. That's handy to get kind of started versus just giving it a default managed policy. Even that tool, you're going to do that like 3 or 4 times per use case. I don't know why it misses some actions, but it just misses some actions you definitely still need. So it takes time to do that for each use case. But it's really worth it because if your Terraform pipeline gets breached or someone gets access to the EC2, having that system have less access is going to be one of the most important incident response or defensive features of your environment. So I can't stress how important IAM is to this. In AWS, IAM also has really interesting conditionals where you can say this policy or this role can't be used outside of this EC2 or outside this AWS org or outside this VPC. So even if someone does some of the techniques that I was showing using like remote exec, and they get that session token and they go outside on their machine and start running commands against your cloud environment, if they're using that role and you have these IAM conditionals in place, they can't do that. Like if they're not on your EC2 or in your VPC, they just can't do it. So they're really powerful ways to restrict these highly privileged roles. And lastly on that, you should really be monitoring the changes to these roles. If you see people or processes changing the policies for your IAM policies for Terraform or whatever pipeline, you should be, there should be some alerting and some notification of why that's happening. You shouldn't really change these rules all that often unless you're adding new services to your environment. So these shouldn't be changing daily. So you should be getting notified if they do change. Patterns are something that I don't think people do a huge amount these days. In larger organizations, there's enterprise architecture, there's building how we're going to use something. Smaller companies, medium-sized companies, they kind of struggle to build these patterns, but it's a really helpful way to basically take, how are we going to adopt this service, document it, right? What features of the service are we going to use, and have that all down on paper, and then you can design your guardrails around that. Perfect example, if you're using like EKS, are you doing like a multi-tenant cluster? Are you doing a cluster per app? Are you doing one cluster for everyone and every lifecycle? All those things should be documented, and then you can build your guardrails to say, this workload can't go into production without this thing being true. And the same thing with IAM policies. You can write your IAM policies based on the pattern. And then that turns into hardened services. So for one of our clients, we have, I think for RDS, we have about 50 policies. For EKS, I think we have something like 70 policies. And when all these run and they all pass, you get a service that's really hardened. You have logging and monitoring in place. You have encryption in place. You have failover in place. And if you do all this work up front, you basically get all this for free with your pipelines. You don't have to go through and kind of fix these things or have your cloud compliance people come in and try to say, tear this down, recreate it. I talked about this, but code review is obviously very important. Definitely use something if you're not doing anything today. Use semgrep if you can. But there's a couple other tools out there that if you're using Terraform, I suggest you check out. They're all free. TFSec has a rule set, Terrascan, and then Checkoff. Checkoff is more than just Terraform, but it has a Terraform rule set. So I basically say if you have a Terraform rule code base right now, run semgrep, run all of them. A lot of rules you'll probably want to ignore or you'll say like it doesn't apply. But just start there, look at everything, fix things, run them again, try to get a cleaned kind of bill of health. But definitely have these types of tools built into your pipelines as well. I'm a big fan of anything that's open source and free. So, and I got to touch on this, but you should really be monitoring these pipelines. We in security kind of ignore pipelines, app pipelines, infrastructure pipelines. And so you definitely should be monitoring these. What are they doing? What are they reaching out to? If your pipeline starts creating resources in like US West 2 or like an Asian Pacific region, why is it doing that? Did you just set up a new business there? If you didn't do that, why is it building new resources out there? Those kinds of activities that your pipeline are doing could be the first indicator that someone has access to it, doing something malicious, trying to set things up in a place you're not monitoring. So that's about everything. I'm a big fan of Terraform. It's a great tool. It's, I think, pretty developer friendly. It's a really good and can be a really effective place to integrate security into. But you have to be aware of all the kind of all the sharp edges of Terraform and all the things that can be done using Terraform. So have controls on multiple layers and monitor it really closely. So thank you. Any questions?
Hi. So does Terraform works properly with the new set of instance meta?
Metadata.
Yeah.
Yeah. Because it's using the AWS SDK underneath, and basically all the SDKs just invisibly update to version 2 if you have it enabled. So yeah, it does. So you bring up a good point. All the metadata stuff I talked about. If you turn on metadata IMDS v2, which does the whole like challenge and response, that defeats that. But we don't see a lot of people have that turned on by default. It is being turned on, I think, in all new AMIs from AWS, the AWS Linux. I think it's going to be on by default now. So that's good.
Yeah. Thank you.
Yeah. Anything else?
You mentioned a bit about like dynamic resources that I created as the plan. So for that case, is afternoon known the only way to actually identify those, or there is some sort of like static analysis that we can do to prevent that possible problem?
You can write modules in a way that try to like if you use things like dynamic blocks in Terraform, that almost always ends up being after unknown. Dynamic blocks are basically ways to do like options in a module to say like if you pass in this parameter, it'll be defined, but if you don't, it won't exist. But it's like a non-required parameter. Using those types of things for anything important, like an encryption setting, it's going to end up after unknown. So if you do things that are more hard-coded, like out of your module or your resource definition to say like encrypted equals true, that usually will not end up being after unknown. The really basic attributes don't end up being after unknown as much. It's usually the relationships. Anything like we've seen where people will use a naming convention, part of the naming convention is after unknown because it references another value, and that value doesn't exist yet. So anytime you're doing references between resources, that's when you see after unknowns a lot. So, yeah.
Thank you. And one more question. Are you familiar with Atlantis? It's kind of like an orchestrator of Terraform.
Yeah, I haven't used it as much as Terraform Cloud, but yeah, familiar with it.
And could it be possible to use Atlantis to catch some of those things to actually avoid the problem?
I think Spacelift and Atlantis both have OPA built into it. I don't know how big the policy set is, but you can basically write OPA natively in Atlantis and Spacelift. So,
Thank you.
sure. Cool. All right. Well, thanks a lot.